In this lesson, we're going to examine how to balance scales using multiplication and division. I'll start this by explaining what the balance scale is to you and show you instances where we balance a scale using multiplication and other instances where we balance the scales using division, and then we'll look through some examples together. So let's look at the balance scale again. A balanced scale must have the same value on both sides, say quantity, same value, almost like a seesaw. So think about it this way. You're looking at, for a scale to be balanced, you have two, if you're looking at a seesaw example, you have two people on both sides of the seesaw that weigh exactly the same, that have exactly the same weight. If one is heavier than the other, the seesaw tilts towards the one that is heavier, and so you don't have a situation that is balanced. So in this example here, this seesaw on the left hand side, you can see that this is 15 right here and this is 5, but because 15 is heavier than 5, so what happens in that case, the seesaw tilts toward the heavier side of the scale. Now, what can we do to balance this out? In this case, we're using multiplication. So what we're saying here is we can actually instead of having one person that weighs 5 pounds, let's use that as an example since we're dealing with a weight. If we have 5 people, if we have one person that weighs 5 pounds and one person that weighs 15 pounds on the other side, what we can do is to balance this out is we can have 3 different people that weigh 5 pounds on one side to balance it out with the other side. So that's what we're going to look at with this type of examples. So let's look at multiplication. So what we're saying here is, in the case of multiplication, we're going to find a way to balance the scale by multiplying a number by the value on the lighter side of the scale to make it balance with the number on the heavier side. So for example, if you look here, we have 7 on the left hand side and 21 on the right hand side. So what are we going to do to balance the scale out? So what we're going to do here is figure out how many 7s do I need to add to this side to make sure that I have 21. So I need 7 plus 7 plus 7. This is going to give me 21, or I can say 7 multiplied by 3, which is also going to give me 21. So if I have 3 people that weigh 7 pounds each, of 3 objects that weigh 7 pounds each on the left hand side, I'll be able to balance the scale out with the right hand side with 21. So I'm going to multiply 7 by 3 to get me to 21. Now, when we're looking at division, it means that there's on one side of the scale you have a larger number. On the other side of the scale you have a smaller number, and you have to divide here. Multiplication by fraction or division, they're about the same thing. So what do I need to do to 12 to keep it balanced with the side that has 4? So what we can do here is we have 12 divided by 4 equal to 3. So what I can do here is I can divide 12 by 3, or I can multiply 12 by 1/3. So what I'm saying here is let's draw something here that has 12. I hope I can get that. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So what I'm saying here is I can divide it into 3 parts. Okay, so this is one right here. This is another set right here. This is another set right here, and then this is another set right here. So you can see that I have 4 different groups here. That's what we mean here. So let's look at some examples. Find the value of the unknown quantity in the scale below. So I have 3 on the left hand side, I have 15 on the right hand side. What do I need to multiply by 3 to get me to 15? So all I have to do with that is 15 divided by 3. That's going to give me 5. So I'm multiplying by 5. So what I'm saying here is, if I have an object that weighs 3 pounds here on the left hand side and an object that weighs 15 pounds on the right hand side, what I'm saying here is I need to make sure that there are 5 of the same objects weighing 3 pounds to balance this scale out. Find the value of the unknown quantity in the scale below. So we have you have 5 objects that weigh 6 pounds each. So 6 multiplied by 5 is 30. So I have 5 objects that weigh 6 pounds each, or 6 objects that weigh 5 pounds each. It doesn't matter what direction you go. So now we're saying here that if I have an object that weighs 10 pounds, how many of such objects do I need on this side to balance out with the side on the left hand side? So all we have to do here is 30 divided by 10. That's going to give us 3. So here I just need 3 objects that weigh 10 pounds to balance out with this left hand side where you have 6 objects that weigh 5 pounds or 5 objects that weigh 6 pounds. So find the value of the unknown quantity in the scale below. So I have 6 multiplied by 4. This is going to give me 24. And I have 72 divided by an unknown quantity. What do I divide 72 by to get me to 24? All I have to do is 72 divided by 24. You can use the fraction approach or the long division approach. I can divide both sides by 6 and I have 12 and I have 4 here. I can divide both sides by 4. I have 3 and 1. So what this means is I have to divide 72 into 3 equal parts to get 24. Find the value of the known quantity in the scale below. So in this case we have both multiplication and division. So we have 6 multiplied by 3 is 18. 54 divided by our unknown quantity should also give us 18 because of this equal sign here. This equal sign means that they have to have the same value or the same size on both sides. So we can divide 54 by 18. So I divide by 9, I have 2, 6. I divide again, I have 3. So I'm going to divide 54 by 3 to get to 18. This topic is very important as we look at equations, whether it's one step, two step, or multi-step.